domain, range, and end behavior. Domain is all possible values of x. If you see this graph, to find the domain, find where the x starts and where it ends. You can use a ruler to find where it starts. It starts here, then it ends here. Okay, that's projected to the x-axis. Now this is the domain of this function. For this function, the function starts from here and ends here. This is the domain of this function, but without this point. Okay, now for this function, what will be the domain? All of the x-axis, as its continuous function, from the negative infinity to positive infinity. Range, all possible values of y. For this function, let's use a ruler from down to up. The function starts from here and ends from here. So the range will be in the y-axis, starts from here and ends from here. So this is the range of the function. For this function, we start from here and end here, not here. We are talking from down to up. Range is in the y-axis. Okay, for this function, the range will start from here and end to the infinity. End behavior. To know the end behavior of any function, we see how it ends. When the x goes to infinity, to the right. If it's continuous, where is the arrow looking? If it's looking down, so it's going to the negative infinity. F of x will be going to the negative infinity. If it's looking up, so it will be going to positive infinity. Okay, as x goes to positive infinity, f of x will go, look, it's looking down, so it will be going to negative infinity, as the y is decreasing. As x goes to negative infinity, f of x, let's see, the arrow is looking down, will go to negative infinity also. For this function, as x goes to positive infinity, f of x goes to, it's looking up, positive infinity. As x goes to negative infinity, f of x is going to, looking down, negative infinity. Okay, for this function, as x goes to positive infinity, f of x goes to positive infinity. And as x goes to negative infinity, f of x will go to positive infinity. To properly describe the domain and range, we can use three ways: inequality, intervals, set. This is the symbols. Inequality, the upper and lower boundary are represented by these symbols. Okay, if we have 2 smaller than or equal x, so x starts from 2 and going to the infinity. If x smaller than or equal 1, so start from 1 and go to the negative infinity. We have 2 smaller than x. Okay, smaller than x, not smaller than or equal. So 2 is not with us. Okay, so we have an open circle and we will go to positive infinity. If we have x smaller than 1, look, smaller than, not smaller than or equal. Okay, from the 1 to negative infinity. Negative 2 smaller than or equal x, smaller than or equal 1. Start from negative 2 and end at 1. Okay, x is bigger than negative 2, smaller than 1. No equal here, not smaller than or equal. So don't have 2. We'll start at negative 2, but we don't have it, and end at 1. And we also don't have it. Okay, negative 2 smaller than x, and x smaller than or equal 1. Okay, we will have the negative 2, but we don't have it. Start at negative 2 and end at 1. That's it. It's like the inequality, but it's inside the variable name, then the inequality. and x such that -2 smaller than x smaller than or equal 1. The same here. Say 2 smaller than or equal x, then start from 2 and end to the infinity. X smaller than or equal 1, start from 1 and end to the negative infinity as x smaller than or equal 1. Okay, 2 smaller than x, we don't have the 2, and we go to the positive infinity. X smaller than 1, so to the negative infinity. As we have -2 smaller than or equal x smaller than or equal 1, we start at -2 and end at 1. Okay, we have -2 smaller than x and smaller than 1, so we start at -2. Remember, we don't have it, and end at 1. Remember, we don't have it, and it's smaller than, not smaller than or equal. Okay, -2 smaller than x smaller than or equal 1. We start at -2, as 2 smaller than x, then end at 1, but we have the 1. Okay, for the intervals, the interval is a part of the number line without any breaks. A finite interval has two endpoints, which may or may not be included in the interval. An infinite interval is unbounded at one or both ends. Let's look at this inequality. 2 smaller than or equal x. How we turn it to an interval? We look at the lower boundary, which is 2. We have smaller than or equal, so we have 2. So it will be square brackets 2, then positive infinity. But we don't have, we can't reach positive infinity. So it will be arch bracket. Okay, start from 2 and end at the positive infinity. From 2 to the positive infinity. Okay, let's say 2 smaller than x. So we don't have the 2 because it's smaller than, not smaller than or equal. So the interval will be arch bracket 2, then positive infinity. Also arch bracket because we can't reach the positive infinity. We start from 2, then to the positive infinity. X smaller than or equal 1. Okay, we already have the 1, so it will be square bracket, but we start from the negative infinity because x is smaller than or equal 1. Okay, from the negative infinity to 1. X smaller than 1. We don't have 1, so we start from negative infinity, arch brackets, to the 1 is arch brackets. Okay. For the given graph, find the domain in equality form, in interval form, set form, range in inequality form, in interval form, in set form. Then the end behavior. Okay, to find the domain, we will look where the x values start, from the left to the right. From the left to the right. Okay, we start here at -6. So we start at -6 and the function is continuous toward the positive infinity. So the domain in the inequality form will be -6 smaller than x because we don't have the -6. Okay, in interval form we will have arch bracket -6 to the positive infinity. In set form, same as inequality form, but we have curly brackets x such that -6 smaller than x. For the range in the inequality form, we'll find where the function starts, from down to up. From down to up, it starts from here, from -4 to the infinity, as the function is continuous. So -4 will be smaller than or equal y. In interval form, it will be -4 square brackets, as we have the -4 with us, to the positive infinity arch brackets. In set form, it will be the same as in inequality form, but we have curly brackets y such that -4 smaller than or equal y. For the end behavior, the function is only continuous for the positive infinity. So as x goes to the positive infinity, f of x will go to the positive infinity as the function is increasing. Okay, thanks for listening.